Now let's look at a word problem that involves a percent. Everybody's favorite. This is number 4 from the section 2.5 notes we covered today in class. So the problem says Amy paid $102 for a pair of shoes during a 15% off sale. What was the regular price of the shoes? So we know how much she paid for the shoes at the discounted rate. We want to find out what the shoes originally cost before the sale started. So I'm going to approach this problem kind of like I approached the tax problem that we did in class. I'm going to make myself a little template, and it's not a mathematical equation or anything. It's just kind of how I approach the problem, what I think about when an item's on sale. So what goes through my head is that I have the original price of the item, so original price, and I get to subtract off a discount. So I get to subtract off a certain amount of money, and that's going to give me my sale price. So 102 is the sale price. That's how much she ended up paying for the shoes during the sale. So I know that whatever equation I come up with, it's going to be equivalent to 102. And I'm looking for the original price because that's what my question is asking. It asks, what was the regular price of the shoes? So that's my unknown amount, and I'm going to represent it with an X. Now the discount I know is 15% off. So I'm going to put 15% here, but the big mistake I see is this. Students say, oh, minus 0.15, and then they solve the equation from here. But you have to remember, you never have a percent just floating around in space. You're always taking a percent of something. And in this case, my discount, that 15% off that I receive, is based on what the original price of the item was. So I get to take 15% of the original price and back off. So 15% of the original price. I'm going to calculate 15% of the original price and subtract it off of the original price, and the result will give me that sale price. So instead of just having 15% floating around in space here, I'm going to do 15% of, so that 15% times the original price, which I represented with an X. So now I have an equation, and I can simplify it and solve it like I would any regular equation. So I have X, and I'm subtracting 1500ths X from it. So I'm going to write in the understood coefficient here, that understood 1, to help me get a sense of the problem. So this is telling me for every dollar of the original price, I'm getting to take off 15 cents for each of those dollars. So if I had $1, but I took off 15 cents, I'm only paying 85 cents on the dollar for that pair of shoes. So for every dollar of the original price, if I get 15% off, I get to take 15 cents off of every dollar that that shoe originally costs. So some of y'all might be able to jump straight to this equation without having to do this thought process. If something's 15% off, then I'm only paying 85% of the original price there. So there's two ways to think about it. If you can jump straight to this equation, no worries. If you need the thought process to help you arrive there, that's good too. But once you get to this point, once we get to 85% of, or 85% times the original price, then we can just solve it in a one-step equation. Since the 0.85 is being multiplied to my unknown value, I'm just going to divide both sides. Okay, so any number divided by itself, except for 0, divides to 1, so I'm left with 1x over here. And when I divide that, I did not bring my calculator, so I'm going to say 120-ish. Okay, don't quote me on that, but I'm going to guess that's going to be 120.
It is.
It is? I have it confirmed. It is 120. Awesome. So this X is representing my original cost for the shoes. And I could go back and check that if I wanted to. I could think, okay, if the shoes were originally, $120, I could either do mental math or any kind of trick I used to do for shopping to figure out the discount. I like to do the 10% trick. So I can calculate 10% of this pretty easily by moving the decimal over 1 point, 1 decimal place. So if 10% is $12, then half of that, 5%, would be half the amount, which is $6. So if I added those percents together, 15% is $18. So 15% discount would mean I could take $18 off the original price. And sure enough, if I do $120 minus that 18% discount, I'll get the sale price of $102. So I checked my answer, I know I got this one right, and I can move on to the rest of the word problems in the packet. Okay.